So we're going to make ionic compounds, and for right now we're not going to use the periodic table. We're just going to use positives and negatives, and so I have them all in different colors around here. So the first thing we're going to do is we're going to use a positive 1 and a negative 1, and we're going to see how they fit up. So the positive ion is going to be A, and the negative ion is going to be B. So we're going to have one positive and one negative. So they equal out in size. There's 1 and 1, and so it's overall neutral. So there's one of each. So you can either put a little 1 if you want to note that, but you don't necessarily need 1 because just the fact that there's an A and a B means there's one of each. But we can put them for now. Okay, so part B says that we're going to use a +1 and a -2. So I'm going to keep my +1 there, and now I'm going to get a -2. So there are more minus charges than there are positive charges. So basically I need another positive charge. So I need another +1. So in my 1 + 1 and -2 category, I needed 2 A's and only 1 B. So again, you can write the 1 if you want to, but I'm going to leave it just there because there's at least 1 B in that position. Okay, next we're going to use a +1. For part C, a +1 and a -3. So my -3, it's nice green. All right, so they don't match up. They're not neutral yet. There's way more negative. So I need a second and a third +1 to make this one neutral. So now there's +3 and -3. So there's 3 A's, but there's still just one of the B's. Okay, next part D, we're going to do a +2 and a -1. So we're going to use completely new ones. Okay, so we're going to have a +2 and a -1. Those don't match up, so we need another -1. So now for this one, there's only one plus charge, so we're going to have 1 there, and 2 negative charges, so B has 2. Okay. So now part E, it's a +2 and a -2. So we're going to take the +2 we already have, and we're going to take our -2, and those are neutral. So we just need one of each. So we can just leave it like that. Okay, then part F, we need a +2 and a -3. Okay, so those ones don't equal out. And you can't just throw another charge on there. It has to be the same substance. So we know we need more positive, so we can put another +2 there, but that still doesn't equal out. Now there's more positive. So I'm going to try to have another -1. Now there's still more negative, so now we need another positive. So now we have 2, 4, 6, so that's overall +6, and we have -3 and -6, so that's overall -6. So now it's neutral, +6 and -6. So in this case, we needed 3 +2s and 2 -3s. So 2 of our negative charges. Okay, now part G, we're going to use a +3 and a -1. So we have +3, -1. Those don't equal out, or those don't become neutral. So we are going to add more -1s until it's neutral. So now there's 1 of substance A, and there are 3 of substance B. So it's AB3 in this molecule. Okay, part H, we're going to have a +3 and a -2. Okay, this comes into the same problem we had with the +2 and -3. So now we need more negative charges. So I'm going to take another -2. Okay, so now there's more negatives. So now we need another +3 in this sense. And we still need more negative. Okay, and I did not cut these perfectly. So there we go. That's a little bit better. All right, so now we have +6 and 2, 4, -6. So +6 and -6. So now it's overall neutral. So we needed 2 positives and we needed 3 negatives. So it's A2B3. All right, then the last one, we need a +3 and a -3. So we have a +3 and then we need, so here we go. And we need a -3. So there's one of each and they're neutral. So we just need 1 and 1. So we just leave it AB. Okay, you can pause it. So we are going to look at a bond between aluminum right here and oxygen is over here. Okay, so when we talked about the periodic table, we talked about how they have a certain number of valence electrons. So this whole row has 3 valence electrons. So it's going to have a charge +3 because everything on the left side of the periodic table, those are all positive charges. Okay, so over here on this side, these ones have 7 valence electrons. These ones have 6 valence electrons. So this charge is actually -1. Everything in that row is -1. And everything in this row is -2. Okay, so that's why I have a +3 and a -2 here because aluminum is +3 and oxygen is -2. And if you want to continue filling in your periodic table, we also have a -3 in this row right here. So it goes -1, -2, -3. This one's +3, and then we would skip all the way over here to +2 and +1. And this follows the group numbers that they are in. Okay, coming back to our aluminum and oxygen. So we have +3 and -2. So we have the same problem that we had with our ABs. They're not balanced out. So this kind of walks you through it. We need another negative. And that would give us a little too much negative. So we need another positive. And then we need a third negative. So overall, this is 3 + 3. This is going to be +6. And -2, -4, and -6. So this is overall -6. So it's +6 and -6. That means it's neutral. So the formula for this one is Al2O3. So this was like our A2B3 that we had previously, but now this is using actual elements. A is the aluminum and B is the oxygen, our positive and our negative substance. So we need 2 positives and 3 negatives. And so your teacher is going to walk you through the rest of the examples on your Zoom meeting.